Welcome to Math TV with Professor V. It's Wednesday, March 22nd, 2023. Here's your integral of the day. We have antiderivative of cosine t over sine squared t minus 9 sine t plus 14 dt. So go ahead, pause the video if you want to try this on your own first, and then I'll work through the solution. Starting off, we're going to do a u substitution. How did I know that? Well, I see a whole bunch of signs down here in the denominator, and then one little lonesome cosine t dt. So it would be perfect if this was du, right? And then it could just get absorbed and cleaned up. So I think backwards. If I want this here, this cosine t dt to be du, who would u need to be? U has to be sine t in order for that to work out. So then du is cosine t dt. So now let's rewrite our integral all in terms of u. So I'm going to have 1 over u squared minus 9u plus 14 du. All right, and then we've made ourselves a nice little rational function here. Our integration approach when this pops up is to use partial fraction decomposition. So now off to the side, I'm just going to figure out the decomposition. We're going to factor the denominator. It factors into u minus 7 and u minus 2. Those are both linear, non-repeated factors. So I'm just going to have a over u minus 7 plus b over u minus 2. And now we need to solve for a and b. So I'm going to multiply everything through by the LCD, which is u minus 7 and u minus 2. So we have 1 equals a. U minus 7 will cancel. So times u minus 2 plus b times u minus 7. Now there's a couple different ways you can solve from here. You can multiply everything out, or I'll show you my favorite method. I choose to let u equal different values that will make each of the factors equal 0, one at a time. So I'm going to let u equal 2 first, and then we'll have 1 equals a times 0 plus b times negative 5. So 1 is negative 5b, which means b is negative 1/5. And then you just repeat that again, and this time we're going to let u equal positive 7. So then I have 1 equals a times, I'm plugging it in right here. 7 minus 2 is 5, plus this is going to be b times 0. So 5a is 1, which means a is 1/5. Okay. When you have irreducible quadratics in the denominator for your partial fraction decomposition, though, this technique won't work to solve all of the constants usually. So you have to use a different method. You could check out the video. I have it in the description box about partial fraction decomposition if you need a review. Okay, so now we have the following. Yay. There. Okay, a was over u minus 7. So we have integral 1/5 over u minus 7. And then since b is negative, I'm just going to write this as subtraction. Okay, minus 1/5 over u minus 2 du. Don't forget that. And then I always encourage my students, take out the constants outside the integral whenever possible. So see, both of these terms have a 1/5. Let's pull it outside. It's just going to make things so much easier, nicer, cleaner. It'll simplify your life. And the cleaner and simpler things look, less likely you are to make a silly mistake, you know? You don't want to be surrounded in a sea of chaos while working on math. It's hard enough. Okay, now we just integrate. I don't need to do a u sub, because if I were to do like another change of variables, there's just a 1 in front of this u, so it's not necessary. Just make sure you keep the u minus 7 all together. So we're going to have 1/5. Antiderivative will be natural log absolute value u minus 7 minus natural log absolute value u minus 2. Close up the brackets because the 1/5 applies to all of this, and then put your plus c. Good. We're not done though. No. So remember, originally we let u equal sine t. So let's go back there. So 1/5 ln, and you do need to keep the absolute values. Sine t minus 7 minus ln absolute value sine t minus 2. Close up the bracket, then the plus c. And I actually put this on the last exam I gave my students. If they stopped here, I gave them full credit, but it does look better if you use your log properties and clean it up. ln, then you can put absolute value sine t minus 7 over sine t minus 2, right? Combine them using division, and then plus c. So it's spring break for us. They're probably not watching my YouTube channel right now, but if they are, you got full credit even if you stopped here, okay? Good. Hope you enjoy the integral of the day. Give it a thumbs up, please. Subscribe to my channel if you haven't already. Leave me a comment down below. Let me know how you like this integral, what your favorite ones are. I can take requests for integral of the day. If you haven't checked out my playlist, I have full video lectures for calculus 1, 2, 3, pre-calc. And then if you want to join my Patreon and have access to exclusive content and request videos weekly, the link is in the description, and it should be popping up right now too if you want to sign up. Have a great one, you guys. Bye.